Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is enhancing user experience through push notifications on Windows Phone using Windows Azure. The topic, and this is the sixth session in the cloud computing series which we have going on TechGig at present. Our guest speaker today is Mr. Manish Menon, Lead Education and Research at Infosys Limited. Mr. Manish gathers an overall experience of 10 years in the areas of IT and engineering, Microsoft-related technologies, Windows Azure, application lifecycle management are his key areas of work. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Manish.
Thank you, Mohini. Thank you very much. Good afternoon to all participants of today's session. I hope my screen is visible to all of you. Mohini, can you confirm if before I start the session?
It's not yet visible. We're just waiting to see your screen.
Okay.
We can see the screen now. Manish, we can start.
So you can hear me, Mohini?
Yeah.
Yeah. So once again, hello to all participants for today's session on Windows Phone, push notifications on Windows Phone, and to add to it, push notifications on Windows Phone using Windows Azure. Okay. So Mohini, thanks for introducing me. I'm from Infosys. I'm part of Education and Research, lead ENR. To set the context right, we are going to talk about push notification. That is the essence of the session today. I'm going to help you understand what is push notification. I'm going to give you a kind of business scenario, a small example that can help you visualize when we need push notifications. And then I'm also going to help you identify what are the different frameworks or infrastructure that we have today that can help send push notifications. Okay, so we are going to understand what is push notification. We are going to understand when we need push notifications, more with specific to Windows Phone. We shall see what are the different frameworks that help send notifications, and then I'm going to deep dive into that specific area for today's session, which is push notifications in Windows Phone. And then, yes, Azure plays a big role in it. So what exactly is a notification service? You know, notification service is not something that has come up today. It's been there for some time. So what exactly is a notification service? Now, if I have to correlate it and try to give you an idea, it is nothing but real-time updates. Okay, so what is this real-time update? We are talking about apps. We are talking about mobile devices. We are talking about real-time updates for apps that run on these devices. You, me, anyone, we all love being informed, right? We want to be informed as soon as there's some fresh message. So let's put it this way. I want to be informed of some fresh message, but I do not want to pull or fetch the data. That's how I want to be. I want a real-time update that is sent to me, not pulled by the client. Technically speaking, not pulled by the client, but pushed by the sender. So if I have some developer community over here, they would quickly correlate it and say, yeah, isn't Manish talking about something like a subscriber publisher model? It's precisely that. If I have an app, or there may be any number of apps on my device, if I subscribe for a notification, I would receive a message. That's push notification for you. Any kind of device, be it an iOS device, an Android device, a Windows Phone, maybe it's a Windows Store app that runs on a Windows 8 operating system, whatever be the platform, I can have apps that can receive notifications provided it subscribes for it. You know, I'm going to, maybe there's a small delay as and when I go through the slide. Sorry about that. So I was just setting the context right. I'm going to help you understand what is a push notification service. I'm going to help you understand what is the certain need for a certain Azure technology out there that can help in the push notification service. But let's try to help you visualize when you need a certain push notification. So you understand what it is. It's a real-time update. So if I slowly move towards giving you a certain business scenario, okay, say I'm a kind of an employee or an employer rather, let's put it that way. I run my business. I have got employees who work under me. Now to all my employees, I might be assigning some work, or you can say I assign tasks to them. I'm going to set some kind of work item, and all my employees, they are going to maintain a certain to-do list. They want to know what they have to do. So at the end of the day, it could well be that my employees have some unfinished work. So if that is the case, is there a way, me as an employer, I can inform my employees about the status of work? So at the end of the day, can I use something like a push notification service? That's one kind of thing. The idea is I want to reach out to my employees. I want to reach out to my employees no matter what medium it is, either to the phone or to the desktop or to some mobile platform. I want to reach out and tell them through a message that there is something pending. So you will see on your slide there is something called a business scenario that I'm discussing right now. I do not need to explain push notification with business in mind. It's not entirely enterprise. You see, if you take a look into the devices that we have, precisely the mobile devices, be it an Android, be it iOS, be it Windows Phone. I'm not going to separate between any of these devices. You know, notification can always be seen as a solution to tackle multitasking. Why do I stress on multitasking here now? You know, generally it is that if you have applications running on your phone, you have one application that runs on the foreground. We generally expect a previous application that was running before I moved to a new application to be running in the background. It doesn't happen that way. Okay, so suppose I am working on a certain social networking app. Say I am tweeting. I'm tweeting, and while tweeting, I decide to run another app. It may not be that I have to jump from one app to another app. It could be that I receive a phone call while I'm tweeting. Okay, in a phone, multitasking does not happen. So what happens to a certain Twitter app? Say the app that I was using was a Twitter app. What happens to the Twitter app that was open? It gets stoned. So if you understand Windows Phone very well, Windows Phone has got a series of life cycles. So the current app that was running, it goes to the background. We think it might be running in the background. It is not so. The process is saved, but it's not running. So while I'm talking on the phone, or while I have navigated to a second app, you know, it could be possible that if there is push notification supported by the first app, then push notification can update the first app's tile. So while I'm talking on the phone, I can see that there are actually 3 new tweets that have come my way. So if I suddenly see that a tile gets updated, I might feel that, yeah, the first app is actually running in the background. On the contrary, it is not. Fact of the matter is providing a workaround, making one thing that multiple apps are running simultaneously. I'm using the concept of push notification to provide something like a simulated feeling. It is not real. There is no multitasking. So whether it be the case of an employer who wants to reach out to his employees, or be it the case of me having simulated multitasking in my phone. It's one of the features of the phone. I can use push notification. Coming back to the business, let's talk about enterprise. Let's see how it is best used during enterprise, because that is how I have modeled my 1 hour session. So if I have to reach out to my employees, they may be using a phone, they may be sitting on their machine. So I can now send a push notification to maybe a Windows Store app. They're sitting on a desktop, they have a Windows 8 operating system running. So I can think about sending notifications to a Windows Store app. Or maybe it's to an iOS device, or maybe it's to an Android device, or it's to a Windows Phone device. If none of these, it could also be that I have to send notification to a certain non-mobile platform, something like a Windows 7. It's not I can consider a mobile platform. You know, there are multiple scenarios that I'm trying to put forward. It could be that me as an employer, I have to send only one notification, few notifications, or maybe I have to send millions of notifications to all the employees who work under me. What I'm trying to come to at is, I want you to understand that while sending notification, I'm the sender. I have to look at multiple scenarios like cross-platform, maybe scalability. You know, it could be a scenario where I have to implement some kind of a filter. What is this filter now for? There may be any number of people who have subscribed for the notification, but it could be that only a selective message should reach few. They do not want all. So possibilities, many possibilities. The question then is, does the push notification services that we have provide a one solution to all these possibilities? You know, if you take a look into the screen that you see on your slide right now, there are 4 options. We have identified a certain service bus notification hub. That is one framework, one solution. It might be covering one of these scenarios that I've told you. I'm not going to depth right now. Or it could be an Azure mobile service. That's also in preview. That can also provide solution to one of the scenarios that I pointed out. The third one is important from today's context. Implementing custom push notification service. Custom push notification service. You know, the fourth one that I have mentioned here, which is service bus topic, it is not exactly a push notification service. It is not exactly identified as a push notification service. But then there are limitations. We talk about the Windows, the Azure mobile services. We talk about the service bus notification hub, the custom push notification service. They all have some limitation. When we come to that particular slide, we will talk about limitations. I'll just give you an idea how a non-push notification service can actually help circumvent few things. So continuing with what we have. Let me jump directly, since we have lost a little bit of time. Let me just jump directly to what we have to concentrate today on. We are concentrating on mobile phone and exclusively Windows Phone 7. I'm not looking into Windows Phone 8, but whatever I'm going to tell you today, whatever code I'm going to show you today, is applicable irrespective of whether it's Windows Phone 7 or Windows Phone 8. You know, what you see on the screen right now, the slide number 6, I've given you a brief definition there. If I were to read it out, there is something like a Microsoft push notification service in the definition. And then it talks about creation of a certain persistent channel. And then it brings forth a certain Windows Phone app. Which means if I have to deal with a push notification, if I have a mobile phone in my hand, if it has to receive a notification, there is one thing that is going to be very important. There has to be a channel that is created between the phone and a certain Microsoft push notification services. Generally, there are 3 stakeholders. There is always a receiver, there is always a sender of push notification, and there is always a certain Microsoft push notification service that is the notification engine that enables push notification. Let's not try to understand everything. We only need to know one aspect which is very important, and hence I have put it right in front, even before we deep dive. What you have to understand from your end is, if there is a mobile device, you always have to create a channel between a mobile device and a push notification service. It may not be Microsoft push notification service. It can be a certain Windows notification service or an Apple push notification service or a Microsoft push notification service, depending upon which platform we are dealing with, but there has to be a channel. So we'll keep that also on the side. So I'm just trying to get you introduced to a few things before we combine all of them to get the real picture. Okay? If you're working on the phone, more specific, if you're working on the Windows mobile phone, what are the different ways in which you can get notified? There are basically three kinds of notification. There is the toast notification, there is the tile notification, and then there is the raw notification. All the three are very important. So what's a tile? You may be aware of what a tile is because we get so much advertisements on TV, the Nokia phone. They're icons, but they're updatable icons. What do I make use of these updatable icons? I can actually use an app tile and visually update it with a message. That is what I'm going to use it for. So if I know the concept of tile, I know that there is a certain front view of this tile. I know that there is a back view or the rear view of the tile that's shown on your slide right now. You can have the tile interchange, the front view and the back view, and in my back view I can actually go ahead and get a message displayed, a visual treat. Or I can go for certain toast notifications. That again, a small description I've given you on the screen. So what is toast? There's a window that comes on top of your mobile device. It's a simple window which will have a text message in it. And then it could be that it also has a sound to signal that there is a new push, something of that sort. So you have a certain tile way or a toast way of actually giving a visual update of a new message that has just been pushed word to the operating system. Mind you, the push is always to the operating system and the push is generally not to the app. It's always to the operating system. And then, yes, there is one more way, though it's not a visual treat. You also have a certain raw notification. A raw notification where information is delivered as mere raw data. The application can use it. If the application wants, it can get that information and display it as a label. But it is not going to appear as a tile or a toast. Now, let me move forward to the next slide. It might take a few minutes before the next slide appears on your screen. We talked about what is notification, real-time updates on apps. We talked about a few scenarios that can help you understand when you need notifications. And then I just briefed, there are 4 ways or 4 frameworks that are available for you to push notifications. Also giving an idea was that if you are considering the phone, the Windows phone, it provides you 3 ways in which you can actually receive the notification. So everything is about the phone, and there is a push notification service which is actually a service on the cloud. Why do I have a particular slide where I'm mentioning about need for cloud services? What more? What is it that is limiting in a certain mobile phone that in order to implement a push notification, that is a custom push notification, I need to depend upon a certain Windows Azure? So I'm assuming that since this being somewhere like the 6th session on cloud computing, a lot of you, if not all, a lot of you are already aware of what is Windows Azure, what is cloud computing, what is the Windows Azure platform, what is Windows Azure App Fabric, what is the SQL Azure, the compute, the storage. I'll give you a brief idea. But what you have to understand is pushing notification on the cloud, on the phone, does not mean you need to know only the phone. You know, why is it that you have to look beyond the phone to get a few things done? A mobile phone, no matter whether it's an Android phone or an iOS or a Windows phone, when you compare it with the desktop, you can say you compare it with a certain server machine. It will always be a limited resource device. What is so limited in a mobile phone? Everything. Like the battery life, the CPU, the GPU, the processing capability, the connectivity, the bandwidth, storage spaces, memory. I gave you an idea about multitasking. No multitasking. That's the limitation. I'm using a certain push notification to simulate multitasking. A mobile phone, when you compare it with a normal desktop or a server machine, is always a limited resource device. So what is my learning from that? Is it that we don't do anything on the mobile phone? No, it's not so. I'm ultimately going to create an application on the phone. Now, what is the application that I'm going to create on the phone? Now, I need an application that is going to help me register for a certain notification service, and I need an app that can collect the notification. So I'm just trying to give you an idea. I have a certain mobile phone emulator that is running. Once the screen is refreshed, you'll see that I have a one-page application that is running on my mobile phone. It's a simulator. You can say it's an emulator. So I will always create a client application on the phone, but I will stick to it. I will only create a client application that can register and receive. There are many things that you need to know in the life cycle of push notification. So what is it beyond that? What is it that we need to know beyond a certain client app? There has to be a sender. Ultimately, I'm going to request for a notification. There has to be a sender of notification. There has to be a sender who, based on some logic, is going to decide what to send. Okay. Am I going to run this logic? The logic that decides what to send on my mobile phone? Answer is a big no. I won't do that. So it's not that only I am going to register for a notification. There can be any number of devices on which apps are running, so that there can be any number of subscribers for a certain notification, which means there is going to be a list of subscribers that need to be maintained. Am I going to maintain a list of subscribers in a phone? Answer is no. Am I going to maintain individual subscribers list on independent phones? No. I need to maintain a table. I need to maintain a list of subscribers so that at some point in time when I have to send a notification, I can loop through the table, decide to whom all I have to communicate a certain notification. I have to find a way out of the phone, outside the phone rather, to maintain this information. I was talking about to-do list. If there is a to-do list, at the end of the day, if the to-do list says there are certain action items open, I need to send notification. Where do I maintain this to-do list? Will I maintain it in the phone? No. I am looking at cloud. I am looking at cloud services, namely something like a compute environment, a cloud storage environment, a SQL Azure environment that is going to help me actually run my logic and also hold the data. So I won't speak too much about what is cloud here. I'm assuming that you are aware or at least got introduced to what is cloud. I'll come back at some point in time during the demo, take you through a piece of code to help you understand what all I am going to do on the Azure. Okay, I'll put a stop here on why I need Azure. We can come back to the slide at some point in time later to understand. Because I want all of you to understand that there is a certain flow. There is a certain life cycle of push notification. So all that we have learned till now, what is notification, the different ways in which I can send notification, the different ways I can represent the notification on my mobile device, all that makes sense only if I can help you understand that there is a certain life cycle. If you can understand the life cycle very well, then you can easily develop push notification services. So I am displaying a certain life cycle or a flow of control here on your screen. Let's try to understand what this is doing. So I'm not putting the slideshow on because I have to change between the slides and my source code. Now, if you take a look into this diagram that I have on your screen, I'm getting a message which says there is a difficulty in listening to the audio. Mohni, can you confirm if I'm audible to you right now?
Manish, you're audible.
Yeah, thank you very much, Mohni. So, if you take a look into the slide, there is a flow. Let me just quickly take you to the flow so that we can jumpstart and start developing. You know, there are three stakeholders here. And what is it that we are trying to understand? We are trying to understand how a client can request for a notification. So who is my client? My client is always my phone because it's enhancing Windows Phone using Windows Azure. So here, the first one is my client. That is my phone, which receives notification, stakeholder 1. Cloud service that you see on the right, that is stakeholder 2. That is my sender, the sender of notification. Now, it may not be a cloud service, okay? It can be just about any application that is capable of sending a notification, or it can be any WCF service that you have running in-house. It may not be on the cloud, but we have it on the cloud. We can see reasons why it is best if it is there on the cloud. And then there is a third stakeholder, which is the one that is most important from the lifecycle point of view, which is Microsoft Push Notification Service, MPNS. You know, from one of the previous slides where I've shown you a definition, we did not actually read the definition, but we were able to understand that there is something very important. That is a certain channel. There has to be a channel between the phone and MPNS is what we read there. Why? Because it is Microsoft Push Notification Service, a service on the cloud that sends notifications to the phone. There has to be a channel between the phone and the MPNS for the phone to receive a notification. No channel, no notification. So if I were to read between these lines, okay, there is a channel between the client and MPNS, and MPNS sends notification. So if I were to read between lines, I can upfront tell you that the third stakeholder that we have, which is my cloud service or WCS service, which is a sender for me, they do not directly send notifications to the phone. That is apparent from this definition. I have a sender, but the sender has to route a notification to the client via MPNS. So that is what you have to understand. From the framework point of view, from the design point of view, there are three stakeholders. There has to be a channel between the phone and MPNS. And when it comes to sending, the cloud service or any sender cannot send a notification directly to the phone. It has to route it via the push notification service. So in this particular flow, I'm hoping the flow is clear to all of you. There are some 6 steps there. Step 1, 2, and 3. All the 3 together. Step 1, step 2, and step 3. They are all together about creating a certain channel. You know, if you take a look into this particular diagram, I have a certain mobile phone which has got an app in it, and step 1 says that my app is actually trying to communicate with a certain push client service. It is trying to connect with a push client service to get a channel. So if I take my source code, I know there will be a certain delay between me displaying the source code and you being able to view it. But eventually, retaining and telling you that we are still on point number 1, if you take a look into the code right now, as I show you, the last statement in the series of namespaces that have been written, there's something like a using Microsoft phone.notification. Microsoft Phone has given me the APIs, the namespaces, the classes, the methods that I can use to create a channel. So from the diagram, step 1, my phone was in fact communicating to a push client service that is running inside the phone only, not outside. It's running inside. It is nothing but a series of frameworks that has been given to you. So if I were to include the namespaces, if I were to use the namespaces to develop, can I look forward at using this what you call the certain HTTP notification channel to actually go ahead and create a channel? So at some point in time, the slide is going to refresh and you will be seeing a piece of code where I am using the push client service to actually get the channel. So I hope the slides are clear now. Within the phone, within the application that I'm creating, if you take a look into my source code, I'm trying to create a channel. There's an if part, there's an else part. If channel exists, okay. If the channel does not exist, create one. What do I do to create one? You can see me instantiating a certain HTTP notification channel. So this is my push client service. It is inbuilt, it's given to you. You have to use API. What happens now? That is more about point 2 in your presentation. So I am asking the API, I am asking push client service to create a channel. The push client service, that is this constructor here, the HTTP notification channel in itself is not able to create the service channel. It is internally going to negotiate with a certain MPNS. Internally, you do not have to say add right click and add service reference to communicate with MPNS. No, it is inbuilt in the framework. Your method, the HTTP notification channel, is actually going to internally negotiate with MPNS and get a channel for you. So that was more about the slide where it was point number 1, 2 and 3. So you have a push notification enabled communicating with a push client service which communicates with MPNS, which actually returns a certain notification. Yes, I think there is a certain audio problem. I think my audio is working fine now. It's being restored. I've been repeating the same point, so it's fine if you have missed a certain aspect of what I mentioned. It's all about point number 1, 2, 3 are very important. Within your application, you have to use APIs, that is your push client service, which in turn will help. That's the interface which will actually communicate with MPNS and create a channel for you. So creating a channel is not that important or difficult. So channel may be created. I know that in my slide that I have prepared for you, there is a certain cloud service which is my sender. Channel may be there between a phone and MPNS. Step 1, 2, 3 has been discussed. How does my cloud service, that is a sender, know to which device it has to send the notification? Just because there is a channel between a phone and an MPNS does not mean any sender knows from which device it has to send. So this MPNS, in addition to creating the channel, will also generate a certain URI. We call it a notification URI. So if you clearly read point number 3, in point number 3, we are actually going ahead creating. We are going back to the application after creating a certain URI. And ultimately the whole channel creation is with regards to creating or generating a URI, notification URI. There may be any number of devices, it's not just one phone, many devices that would want to register. So ultimately, from one of the previous slides, we talked about maintaining in a table all the series of notification URIs. We keep it in the cloud. Point number 4 that you see on the slide here. I'm going back to the cloud service to push URI to the cloud service. Meaning, I'm going to maintain a certain table on the Windows Azure platform. Either it can be a SQL Azure or it can be a Windows Azure storage. I'm going to create a table and I'm going to maintain all my data there. That's point number 4 for you. So the channel is ready. In the cloud, I have the content ready. We'll see how content can be made ready. That's more about the development aspect. Somehow it's being done. In addition to registering, in addition to creating the channel, registration has happened. While registration happens, a certain table has been created on the cloud. That is point number 4. Now, my sender is ready to push some notification based on some logic, say based on a certain to-do list. People are registering. There are work items that is pending against people who have registered. I need to notify them. I need to send notification to all the devices, no matter what device it is. What does the sender do? That is stakeholder 3, that is your cloud service. It's going to scan the series of tables that you have. It's simply going to scan the table where you have maintained your username and the notification URI, and it's going to push that message where it cannot push the message back to the device. It is going to push whatever message it has to MPNS. That is point number 5. An HTTP post is being sent to MPNS. MPNS internally is now going to take that message and ultimately deliver it to the device through the channel that has been generated and kept. It can be an authenticated channel, it can be an unauthenticated channel. That depends upon how we want to develop it. So does the sender be kept in dark as to what happens? Sender has to make sure that the notification reaches the phone. Does that mean the is informed end-to-end connectivity? If there is someone who can inform, it is MPNS who can inform, because the sender sends a notification to MPNS, which ultimately delivers. But MPNS does not provide any end-to-end connectivity. It only says that if required, it can return a status code back to the sender and say, yes, I have received the notification message from you. I have received from you and I will be delivering to the client. It does not say, yes, the client has also acknowledged that it has received. That is not happening. So I'm trying to give you a brief idea about what it could be with regards to actual development of push notification. You know, a lot of things go into developing a push notification application. I have shown you a certain Windows phone. In the Windows phone that you saw, you have seen a screen. So that is a client application that is developed. Now, if there is a application, if there is a certain register button, then yes, you saw that there is a code. There is a code that actually goes ahead and does, in addition to launching the application, register a channel. So there is a set of code for that. We have to develop it. And in addition to it, we also saw that there is a need for maintaining a table. So I've been telling about maintaining table and running logic outside. Ultimately, how is it that I'm going to achieve? So from your end, if you have already attended sessions on Windows Azure, if you are aware of the programming model of Windows Azure, what I present to you today is the best way of using a certain web role and a worker role to achieve what we want to do. Now I'm going to get started by talking about a worker role. You know, I want to run my logic outside the phone, and I want to make sure that there is a logic that is run periodically, maybe every 24 hours. But it checks a certain table which has got a series of subscribers identified. It gets the list of all subscribers, and for those subscribers, if there are some to-do items pending, push the notification. I am telling you, there cannot be anything that is better if I have to develop something better than a worker role. Because worker role by definition gives me a certain run method. Run method defines the business. And on start, run, on stop. Lifecycle methods. The run method always runs with an infinite loop. It just keeps running and running. This is my background processing. So if I can use a run method of a worker role and put a certain logic there, which says, yes, there can be a table. Those are the first 4 lines of the code that you see on the screen. Yes, if there is a table, if the table contains the subscription information, then why don't we just go ahead and scan the table, get the list of all the users who have registered, Let's assume that each user who has registered actually has a work item pending against their name. If that is the case, then get the subscribers and then use a series of APIs that are provided to me that can be used as an interface to actually send the notification to whom? To the MPNS. What am I talking about? I'm talking about the backend. In my backend, where I have to write logic to run my notification, I can look at Windows worker role as a possible solution because it provides me with a run method. You see on the screen, at the very last line, I'm saying sender.send toast notification. Now it can be sender.send a raw data or a toast data or a tile data. It's up to me to decide what I want to do. Here in this application that I have in mind for you, I'm sending a toast notification. I'm browsing to the table, I'm getting the data that is to be displayed. It says everyone who has registered, they have something like item number 10 pending. Okay, send it to them. I'm looping. Every 24 hours, I'm going to get the data. This gives you an idea that, okay, there is a certain logic that is running behind the screen in my Azure environment. So I am not looking at using a WCF service for that. I'm not looking at using a certain ASP.NET application for that. I don't want to set any timer and keep it running. I don't want to do all those things. I want a worker role to keep running forever because it's not a one-day task. It has run 365 days a year. So while I showed you the code for the worker role, there was a run method. What was also important was the first 4 lines. Before we entered the run method, it was actually trying to access data from a table. It was checking whether there is a table that exists. People who do not know Azure, it's okay. At least you know that there was a table that was existing. We were trying to scan the table, get the content from the table. What all content? The username and the notification URI. And we were sending a push notification. Specifically toast. What is it about table? I'm saying I want to maintain a table. I'll maintain a table on Azure. But I also want somebody to create the table. I want somebody to update the table. I want somebody to perform the CRUD operations on the table. Create, retrieve, update, and delete. Again, I'm going to depend on a certain Azure compute environment to do this aspect. What I'm going to do, I'm going to create a service. A service that is going to perform the create, retrieve, update, delete operation on an Azure table. It can be SQL Azure. It can be a storage Azure table. It's not important for me. What you see on the screen is few lines of code that is going to help insert a data into a table. Where is this service running? This is a service for you. The service is going to run on the cloud as a WCF service. So you now know why in the diagram I've shown you cloud service as a sender. In the cloud, I'm going to keep running 2 roles. One is the worker role that has the logic and a web role that is going to be the service that inserts data into the table. So worker role can run independently. If there is a service that is going to make an insert, there must be some consumer of that service, right? A service cannot exist just like that. Somebody has to use a service. If you think about it, it becomes apparent to you who the user of the service will be. I have already shown you a screen. In that screen, you had a certain register button on the mobile phone. So the mobile phone does not do much. It's just a client application. It has got a checkbox. If you check it and click the button, the user of that app is going to get registered. Okay. Now, in order to get registered, I need, in diagram point number 4, I need my URI to be kept in a certain table. Who puts the data in the table? There is a service. The service is running on Azure. So who is the recipient of that service? My phone application. In my phone application, I will not run any business. It's just going to have a dummy button. If on click, I'm going to call that service with the sufficient data. What are the data that I'm going to pass to the service? The name of the user who is using the app. What is the notification URI to which a notification has to be sent? In addition to that, I'm also going to make use of some more information. Like I can say, yes, it has to be sent to a certain Windows 8 mobile phone. When you looked into the code, there was a code something like a sender.send notification, send toast notification, right? That was there, what was there in the worker role. That is a Microsoft way of doing this, Microsoft push notification service. If I'm dealing with Apple, that says that I have to now know something like an APNS, Apple notification service. If it's Google, I need to know about Google Cloud Messaging and their APIs. If I'm working on a Windows store, then I need to know about Windows notification service. So you should be able to see on the screen right now who the consumer of the service is. It is nothing but my event handler. Event handler of the client app that is running on the phone. It's a straightforward thing. I click the button, I call the service, and within the service, I'm going to perform the insert operation. So that gives you a round of idea about, yes, what all are the stakeholders. The first stakeholder was the Windows Phone application. The second stakeholder was my worker role. And the third, that's the Microsoft push notification service, which is a service that is running on the cloud. You might have seen that nowhere I have right-clicked and added a service reference to call the Microsoft push notification service. I don't need to worry about that because I have got APIs. I have got something like a push client service that will internally negotiate talking to Microsoft push notification service. So Microsoft provided support for the Windows Phone. So can I run my application? So if you are already aware of a Microsoft way of doing things, so it will take some time for the worker role emulator that is running on my screen to be displayed onto your screen. There is a lag, I think a lag of around 10 seconds. So I have my worker role up and running. I have my web role up and running. The worker role runs the business, infinite loop. My web role, which is my WCS service, is ready. Is there any request that can push notification onto the client? Yes, it is ready, waiting to receive. I can actually go ahead and open my mobile phone and use my mobile phone, click the button and say register. So I'll just wait for a moment for you to see my mobile phone on your screen, because it is important for you to view the mobile phone and the Azure emulator on the screen. So while the page is getting refreshed, I want to keep you updated that I have opened the mobile phone. In my mobile phone, I am adding that I am a certain user 1. The user 1, that is me, would want to register for a certain push notification. Now, the moment I click the button, I'm not clicking the button as of now. I would want the screen to get refreshed. The moment I click the button which says register on the mobile phone, it is going to send a request where it is going to send a request to, I think there is again an audio problem that is happening. I'm getting a message. It says experiencing difficulties with audio conference. I trust the audio has been restored as of now. So in the past few minutes, what I was talking about was, I'm sorry there was an audio disturbance. In the past few minutes, I was explaining to you that yes, I'm going to use the mobile phone. I'm going to click the button which says register. Internally, it is going to communicate with Microsoft push notification service, create a channel, provide me with a notification URI. And in addition to providing the URI, I'm also going to make sure that I call the web service. A lot of things are happening. At the same time, also going to make sure that I call the web service which is running on the cloud and say, okay, kindly maintain a table with whatever data I'm giving you. Whenever the worker role runs, so it's like you have to visualize a lot of things. Whenever the worker role runs, it will scan the table. It will scan the table and say, yes, if there is a certain user, take it, bring it, and send push notification to that user device. So I trust you are able to see my mobile phone right now. You are able to see behind the mobile phone there is a certain emulator that is running. The two things that are running at the same time. On the background, you have two green icons. One is the web role which says the web service is up and running on the cloud. Another green button is the worker role which says, yes, my infinite loop for the logic is running on the cloud. That's my backend that is running on the cloud. And then on the foreground, you see that there is a mobile phone. I'm using my mobile phone. I'm going to click my mobile phone and say, I want to register for the request. I'm saying I want to register. If I click the button and say if I want to register, it is going much beyond to the Windows Azure way. Communicate with the web service. It is going to make an entry into an Azure table that we have in place. From the Azure table, my worker role is going to take the notification URI. It is going to display the notification URI onto the mobile phone. So a little bit slow the screen is going, but over a period of time you will be able to see that there is a mobile push notification that is getting displayed. So I have clicked the button. In my table I have got the push notification URI generated. My worker role is running in the background. It has just now retrieved the push notification URI data, and then I'm just waiting on my emulator of the phone to see the push notification actually displayed on my screen. So it's what kind of a push notification? It is a toast notification. Why? Because the notification that is sent is a toast, and also if you had observed the code, in that few lines of code where I'm creating a channel, I had also mentioned that the channel has to be bound to the toast. The channel is only going to receive for the toast notification, not anyone. Okay, just keep in mind, it's just an FYI, if you are developing an application where you have to communicate with MPNS, then you would rather want something like, so I do not know if all of you have listened to a certain sound. There's a sound that came. That sound was a toast notification sound. You know, by the time the screen is displayed to you, I'm sure it would have gone. So I've just taken a snapshot. Let me just put it on MS Paint here. Let me put the snapshot on MS Paint, and let me put a Control V so that I trust you will be able to see the screen based on the snapshot that I'm providing you. So as and when the screen is refreshed for you, you'll see an image that comes on your screen which says, yes, on the background there is a table. In the table you can see there are a series of information kept, and in the foreground you can actually see a certain mobile phone which has got a push notification displayed on the screen. So I can see that the slide is not refreshed yet. Sorry about that, it's going a little slow, but yes, there is a notification that has just now come up. Is it that there will be only one notification, or is it that there can be many more notifications? There can be any number of notifications, because the worker role keeps running. In the second time it comes after 24 hours. Here I have put it at 2 minutes. If it comes back after 2 minutes, it is again going to read the table. It is again going to get the list of all notifications, requests that are there, and keep sending the notification. So now on the screen, you will see that on the back side there is a table. There is a table where you find that there is a partition key, there is a row key, there is a timestamp, and then there is a column which is called device. In the device you see there is a URI. There is a certain notification URI that is there next to the device actually. Device is nothing but my Windows phone. There is a notification URI which begins with HTTP db3 dot and a certain link that is given. My application, that is the worker role, looks into this particular table structure, gets the URI, and just pushes the notification whom to the MPNS. The MPNS uses the channel to display the certain push brick. You can call it a toast notification, you can call it a brick notification, it's just a terminology, but I do get a window that is modular. If I want, I can implement something like a tile. So in brief, that is about push notification for you. That's how we actually get implemented with push notification. But you know, I'll just take Mogni, I hope it's okay. I'll just take a few minutes more. I have tried to give the audience an idea about how they can develop a lot of things on their own customized way. Life is not always about customized, because when I started the session, I was saying there were 4 ways of doing a lot of things. You know, I've tried to give you an idea about what all you need to know when you go into the real world. But then maintaining the device handlers, implementing interface for every platform. This is a push notification. I have to write the code if I have to deal with Apple or Android or a certain Windows Store app. Depending upon whether it's a toast notification or a row notification or a tile notification, I have to again manage my messages. Lot of things that I have to manage on my own on the backend side. One is that the other 4 options of notifications come into picture. Say, when do I use a certain Windows mobile service? A lot of things, the web role, the worker role, creation of the table. You don't want to do them from your end, don't do it. If you use a certain Windows mobile, or not a Windows mobile, Azure mobile service. The Azure mobile service takes care of your entire backend. You only have to worry about creating a client app for yourself. You do not have to worry about the backend at all. That is an Azure mobile service for you. It makes life much simpler. So while I'm talking, I do not know whether over the phone you have received something like a tidding sound. If you have listened, it is basically a DOS notification again getting displayed on my mobile phone emulator, which means the worker role keeps running. And I'm telling you, all this, if you use an Azure mobile service, you do not have to worry about. The backend is taken care. You click 3 buttons, shortage of time, but we could have gone there. If you click 3 buttons, you are ready with your backend, which helps you with a little bit of scalability, not everything. You know, if I talk about Windows Azure mobile service, yes, there is an advantage when compared to a certain customized way of doing things, because I do not have to manage the backend totally. But a certain Windows Azure service is more better when you are dealing with few amount of people. You know, it also needs a lot of configuration from your end. You still have to configure based on which platform you're going to send your notification to. You have to, you cannot escape. There is nothing like a single API that will take care of a notification to any device. Azure mobile service does not give such a interface. If you're dealing with Azure mobile service, again, you have to continue to worry about the certain device token that is refreshed each time an app is launched. Okay, the toast notification, the what you call the tile notification, you have to identify the messaging structure. It's not that easy, but most importantly, where it fails is the big time scalability that we can expect. If you want to think about that level, you have a new feature which is also in the preview, which is called a service bus notification hub. Big time cross platform. You get your common APIs to send push notifications to multiple platform devices. That it provides. Instead of maintaining device URIs, it provides you with a certain tag-based handle. You know, scalability, it can actually go and send your notifications to millions of subscribers. And on top of that, it can also integrate with a certain Azure mobile service to enhance the working of Azure mobile service. It will happen one day, not yet. It's in the preview. You know, one of the sessions, I think Nilesh Watke spoke about what are the different virtual networks you can have, virtual machines on this virtual network. You can actually have the service bus notification hub connected or integrated with a virtual machine in IaaS. So that gives you an idea of why I need to go to notification hub now. So from custom, we have seen mobile, Azure mobile service, and then we have seen a notification hub. Then why did I give you a 4th point earlier? I was talking about how you can actually go ahead and maybe try to make use of a service bus event topic. You know, whatever strategies we are talking about, say for instance the notification hub, they are all actually designed to push notification directly to the operating system. It's a very important point. Your app is not sitting there and listening to the notification. The notification from a certain notification hub, for instance, is sent directly to the OS. What happens if you are sitting on a Windows 7 machine, which is not a normal, what you call a mobile platform as such? How do you send notification to such a machine, an app running on such a machine? That is when you make use of a certain service bus topic. It is not exactly a push notification service, but we can tweak the functioning of event topic to make it provide a message to an application that is running on a Windows 7. You can use a service bus topic for that. So I do not know if I've gone beyond time. I'll just stick to the basic core that we were planned to teach. We were planning to cover in this 1 hour. It was about customized way of developing the application. I hope you have got a feel of how you can develop. Any questions, you can always get back to me. I want to put forward a question to Mohini and ask, is it time for the question and answer session, Mohini? So I'll just take a look into the questions that we have. I'll just quickly go through the questions and in general summarize them and try to give you an idea about the best way of doing things. So there are questions like, can push notification be customized for certain users? If you want to customize this, more like you have to filter. You have to filter what you call the certain notification that you have. So when you talk about concepts like events, topics, you talk about filters. Yes, based on what notification has to go to which, device, you can appropriately filter it and say, okay, only a certain messages are expected to reach a certain receiver. So there's a question from Tintin Snowy who wants to know about push talk. Is this similar to something like a push to talk introduced by Nokia some years back? I do not know about push to talk, unfortunately, Tintin, but maybe I can figure it out and inform the moderator about it. How do I enhance my experience by receiving push notification on my lock screen with customization? You know, when you are working with push notification, as I spoke, it is not about whether your application is running or not. Your push notification is directly sent to your operating system. So I guess that explains your question stated. It's about you are always directly communicating it to the operating system. So I had a question from Nidhi who wanted to know about customized for certain users. Yes, you have to introduce the concept of filters. You have to introduce such that when a certain notification is pushed onto a hub, the hub decides as to which receivers are expected to accept a certain message based on a filter that can be set. So there's a question from Gokul who asked, when the device receives the notification, will it receive the only message notification or the real data from the app service provider? Gokul, I am looking at telling you we deal with information. I'm not talking about big time data. There is a certain amount of size that restrains on what can be sent. Say, if I were to put forward and tell you that at the most say 1 KB can be sent. So all that you are actually sending is a certain information. It's something like a breaking news. You want to keep yourself informed. It's not the full content. I hope Gokul is clear to you on that front. In a smartphone, while we are browsing through websites, we are able to also read messages on the top of the screen. Is that a push notification? Not exactly. It may be, that's a question from Sridhar Shivkumar. It asks whether the messages that you see on the browsing, you know, maybe if you open your ICICI screen, you go to a browser, you open ICICI, then you will keep seeing that a certain message keeps moving from the right side to the left side. It's more like a cyclic fashion. It goes in a circle. That has nothing to do with push notification. That is real-time update by someone who's sitting there and updating. Okay, it's not about push notification. It's not about push notification. Where does HTTP notification channel find the channel name? Nishi has put forward this question. Nishi, HTTP notification channel, if you open, that is an interface that is being provided to you. You can use that interface. You can create it. What you have to know is remaining things that happen actually happens internally. The HTTP notification channel, if you have observed, it does not upfront tell you that, yes, I am actually dealing with Microsoft push notification service. But you have used an API that will help you communicate with MPNS. You do not know the internals. But yes, definitely the HTTP notification channel is actually going to internally negotiate with MPNS and come back with the channel. There's a lot of asynchronous coding that I have displayed on the screen that you might have seen. It does not come back with only the channel, it also comes back with the notification URI. So I'll just take a couple of more questions before we wind up at 4:15. I have a question from Rishi Agrawal again. If you have multiple applications running with push notification enabled, so there are more than 2 applications running with push notification enabled, then do they have the same URI? Answer is no, Rishi. Every application that is running on the device will have its independent URI. Okay, there can be only one channel for every app, and every app will have an independent channel and a URI, and there is a limit, I think somewhere like 20-25. That would be the maximum number of channels that you can have on a phone. So if there are 2 apps that are running, one app cannot run 2 times. The mobile phone will not help you. So I assume that you have multiple apps or 2 different apps. Both different apps will have their own independent URI. So I'll just take one last question that is displayed here. What will happen in case of multiple Microsoft push notification service server and multiple cloud providers? That's a question that's been put forward by Nidhi Setia. Nidhi, I do not exactly understand what the question is. There is one Microsoft push notification server. Okay. Now, in addition to it, there can be an APN, that's your Apple push notification server. There can be something like a WNS, that's your Windows notification server. Or maybe with regards to connecting to a cloud Android device, you are talking to something like a Google Cloud messaging. Yes, you have to generate your own APIs to interact with them. Okay, I hope I do not look at a scenario where you can have multiple NPNs here. Okay, so I'll just put forward an end to the session here. Because we are running short of time. I'm sorry, there's a couple of more questions that could have been handled today, but I give back the control to Mohini, and I would want her to just inform me how to go about beyond from here. So Mohini, you are there? So let me thank all of you who have attended the session today. I hope you have got an idea about how you can implement a custom notification service using Windows Azure, and how you can send the notification to a Windows phone using Windows Azure mechanism. Thank you all of you. Thank you very much.
Well, thanks for the insightful presentation, Mr. Manish. I'm really thankful to you for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.